All right, let's have a look at this question. So ultrasound can be used on humans. Becky has her body fat measured using ultrasound on her arm. Ultrasound reflects strongly at different tissue layers inside the arm. The body fat layer is just below the skin. The different tissue layers in the arm are fat muscle layer, muscle layer, muscle bone layer. And we're moving on to the question. Why is ultrasound used rather than surgery or x-rays to measure body fat? Explain what the display shows and how it can be used to find the thickness of body fat in Becky's arm. And this is a 6-mark question. Now have a look at the peaks A, B and C on the graph. So on the x-axis you've got distance into the arm in millimeters and strength of reflection on the y-axis. And you can see that the display showing ultrasound reflections. So you've got to explain what those peaks are, A, B and C. Here we've got two different media. So can you see the first line and the second line? And you've got sound waves. So that represents ultrasound. Now, as the ultrasound goes to a boundary, it will get reflected and some of it will be transmitted. And then as it reaches through the second line, that's the second boundary, again, that will be reflected and some will be transmitted. I just didn't draw the transmission. So what you can say is that the peak A and peak B and peak C, those peaks happen at the boundary, and you can say that the waves reflect from the boundary. Some will be transmitted. And then you can say that the first peak A would be the fat muscle layer. So the fat muscle layer will be the first, and then the muscle layer will be the second, and then C will be the muscle bone layer. So these are reflections at different depths. And then you need to include some of the data. So for A, you can see that is above 5. So that's about 7.5. So it's around about 5 or 6. 5 or 6. So that's A. And B is around, peak B is around 15. And C is around 30. So you can talk about that. All right, so we've explained what the display shows. Why is ultrasound used rather than surgery or x-rays to measure body fat? All right, so what's the advantage of using ultrasound? Now, ultrasound is non-invasive. You can say it is non-ionizing because ultrasound is just pressure wave. There's no radiation involved. So number one, you can say it is non-invasive because there's no damage to tissues. You can use ultrasound to measure images. It produces images of soft tissue. You can measure soft tissue depth, the depth of soft tissue. So those are the reasons why you would use ultrasound to measure body fat. Okay, so to answer this question, now ultrasound is non-invasive. So we can say the first point, we can say it is non-invasive. So there's no damage to tissues. No damage to tissues. And it can be used to produce images of soft tissue. So you can say that it produces image, produces image. Okay, so it's non-invasive, there's no damage to tissues. It produces image of soft tissues. First one we can say no damage to the human. Okay, so the third mark, explain what the display shows. So we can say that the peak is at the boundary. So those peaks A, B, and C happen at the boundary, So the waves are reflected. And then we can say that the reflections happen at different depths. So the reflections happen at different depths. And then you can talk about A was, let's just say it's about six millimeters. Was it 6 millimeters? 6 millimeters. And that was the depth of the fat layer. And what else can we say? So why is ultrasound used rather than surgery? X-rays. Explain what the display shows and how it can be used to find the thickness of. So we've said that the reflections happen at different depths. A, and you can say that B and C are depths of different boundaries. So it could be the muscle layer or the muscle bone.